For this fifth lab, I am investigating an Olympic trampoline gymnast. So, some basic concepts behind this lab is that basically the purpose of this lab is to observe a human that is jumping on a trampoline, as you can see on the left. The net force is given by the force of drag plus the force of gravity. So, the two principles that are basically integrated into this lab is the energy principle and the momentum principle. The energy principle states that the change in energy, which is equal to energy final minus energy initial, is given by the work done by the surroundings plus other energy transfers. The work done can be given by taking the integral of the force over a certain distance. For example, if you take the integral of the force and times it, if you take the integral of the force, it would give you the work done, which would give you the change in energy. The force can be constant or non-constant when you're taking the integral. You would take it from the initial distance to the final distance. So, the basic science of jumping on a trampoline. Gravitational potential energy, elastic energy, and kinetic energy is involved. As you stand still, you have potential energy. For a trampoline, it also has potential energy, but in its springs. You use that potential energy to jump, and the trampoline uses that potential energy to push back against you. So, your body exerts its energy against the trampoline with the force of its legs basically pushing off the mat. The mat absorbs this action and then responds by sending the same energy right back in the opposite direction with its elastic energy. And that equal and opposite reaction is basically what pushes you up into the air. So your elastic energy acts against the trampoline's elastic energy, but the trampoline has more elastic energy, so it results in a much larger reaction. Your kinetic energy is also applied to the potential energy of what you're acting against, and the own kinetic energy of that reaction helps determine what the reaction is. So as you jump, you generate more kinetic and elastic energy while you exert potential energy. This is why you can jump higher despite not physically putting so much energy into the jump itself. So basically, you're riding the wave of the initial reaction while putting enough energy back into it to continue the cycle, but not too much as to drain yourself. So analyzing the video, I analyzed the video of basically a woman trampoline gymnast, and this was her graph of position against time, her X position. And here, as you can see, she's twirling in the air, and I put a center of mass on her, and I recorded her X position and her Y position. Here I changed around the code from lab4 a little bit. I added basically the there were the four energies that were already there, so I used those. So kinetic energy, gravitational energy, elastic potential energy, and the total energy. So the kinetic energy was basically given by 1/2 mv squared. The potential was mgh, equivalent to the variables here. And the elastic was 1/2 spring constant times s squared. So the net force was given by F net equals F spring plus F gravity, and the momentum principle was used to update the object's velocity and also the object's position, as shown here. So here is the position versus time. The blue line represents the Y position, while the red represents the X position. As you can see, the Y is kind of sinusoidal, so it has a specific motion, and it's going to repeat itself, and it's going to oscillate because it is moving up and down in the Y direction, but the X direction doesn't really have a specific pattern to it. Here, the change in energy versus time is given. So the blue line represents kinetic, the potential energy is in red, the elastic potential is in green, and the orange 0 is the total energy because there's no work done by the surroundings. Even if there is, I have neglected those in order to keep some variables in check for this experiment. So as you can see, the elastic potential energy is the one that changes the most, which makes sense, as I explained before. And then comes the potential energy, and as you can see, the kinetic energy as well. But as you can also see here, they're all basically moving sinusoidally, so they will all repeat itself as the woman keeps repeating her Y position and keeps jumping up and down on top of the trampoline.